The question says what is the difference between a complex salt and double salt. Okay, complex salt and double salt. Keep in mind, complex salt does not dissociate completely in aqueous solution. Therefore, it does not give the positive test for all the ions present in the complex salt. But in case of double salt, when it is added to the water, it will dissociate completely, and whatever the ions are present, it will give the positive test. We can understand this part by taking one example. For example, let's say we have a FeCN whole 6 and we have Na3 is there, Na3. This is a complex compound because we have coordination sphere is there. Okay. Always keep in mind, any species present inside this coordination sphere will never undergo dissociation. You can see cyanide ion is present. Cyanide ion, if you calculate the oxidation number of Fe, it is present in +3 oxidation number. This is what ferric. Ferric ion is also present. But since they never undergo dissociation in the water, this species which is present inside the coordination sphere will never undergo dissociation. That's why it will never give the positive test for the ferric ion as well as cyanide ion. You can dissociate this complex from here, from the counter. This counter ion is the species which is present out of the coordination bracket. Okay. So when we dissociate this compound, we get, you can see, this is one complex and this is what counter ion. So we can crisscross. So one will go this side, is having +1 charge. In this case, it will be having -3 charge. So we get 3 Na plus, and plus we have it is Fe and it is Cn whole 6 and having -3 charges there. Okay, so you can see it is giving the positive test for the sodium ion, but it does not give the positive test for the ferric ion as well as cyanide ion because it does not undergo complete dissociation. Complete dissociation. Now I take one more example. Now let's say I change the situation of the counter ion. We have Fe and then we have NH3 whole 6 is there, and we have Cl3 is there. Okay. In this case, if you calculate the oxidation number of iron, it is present in +3 oxidation number. Okay, so ferric ion +2 is there, ferrous ion. Okay. Again, you can see the species which are present inside the coordination bracket, they will never undergo dissociation. Okay, but you can break this complex from here because this is the counter ion. Okay. Now we have 3 will go this side, it is +2, and 1 will go this side, this is negative. So we get Fe, this is what NH3 whole 6, and power what we have +3 is there, and then we have 3 Cl minus ion is there. It gives the positive test for the chloride ion, but it does not give the positive test for the ferric ion because it does not undergo dissociation. Okay. So this is the example of complex salt. Complex salt are nothing but complex compound. Coordination compounds, they do not undergo complete dissociation in water. That's why they do not lose their identity in aqueous solution. Okay, some identity will be there. So you can see they are maintaining their identity. This part is there, this part is there, because it does not undergo complete dissociation. But now let's see if I talk about double salt. Okay, we have one double salt, let's say KCl is there, and dot MgCl2 is there, and then we have 6H2 is the carnallite is there, 6H2. Okay, it is present in the crystal form. Okay, this is also ionic, this is also ionic. In case of double salt, when they are added to the water, they will undergo complete dissociation. It will break from here also. So you get potassium and chloride ion. It will break from here also. It will produce Mg2 plus and Cl minus ion. Okay. So you can see whatever the ions, K plus, Mg2 plus, and then we have chloride ion is there. Okay. So you can see all the ions. It will undergo complete dissociation. So it gives you the positive test for the potassium ion, magnesium ion, and chloride ion. Since it undergoes complete dissociation, these double salt in aqueous solution lose their identity. Okay, if you want to determine the property of this double salt this side, no, you will not get the property because it completely got dissociated into ions. It will give the positive test for the ions present in the solution. We can take one more example. Mohr salt is there, very common salt. We have ferrous ammonium sulfate is there. So ferrous sulfate is there, FeSO4. Ammonium sulfate is also there, NH4 whole twice. SO4 is there, and in the crystal form 6H2 is there. Okay. In this case, You can break it from here. Sulfate ion always -2. Then it will be present in +2. Ferrous ion is there. It gives you the positive test for the ferrous ion. You can see Fe2 plus and sulfate ion is there. Very interesting. Plus, you can see ferrous ion. You can see we did not, okay, ferric ion we had, but it does not give the positive test for the ferric ion. Now, from here also you can break it. So, Fer in this case you can see it is 1, it is 2. So, it also plus 1 charge. This also -2. So in this case we are getting ammonium ion. We have ammonium ion, then sulfate ion already written. Okay, you can see complete dissociation. It also loses its identity in aqueous solution. So these are the examples of double salt which lose their identity because they undergo complete dissociation. But in case of complex salt, they do not undergo complete dissociation. That's why they do not lose their identity. If you like this video, please share and subscribe to the channel.